Hello students, welcome to my live teaching learning session of BECE 144 Financial Economics. Today we will start block number 2 and we will cover unit 4 and unit 5. In unit 4 and unit 5, the topic is Grow Elementary Statistics and Spreadsheets. Financial economics. In this financial economics, you must have to learn about basic statistics or general statistical knowledge. So that in this block, we will cover elementary statistics and computer application. But before starting this unit 4 and unit 5, I would like to finish previous session topics, financial risk. Because in last session, we have discussed about financial instruments. And in financial instruments, we have discussed so many primary and derivative instruments of finance. Financial risk is also the part of financial instrument. Because when we are studying this financial economics, in financial economics, first of all, you have to know about what is financial economics, what is the basic instruments of finance, what are the main functions of financial markets, and what is the meaning of financial institutions. And financial risk, you know that in share market or in bonds or mutual fund market, financial risk involved. If we have deposited our money in bank at a fixed interest rate, that there is no risk. But if we invest our money in securities or in financial asset or in paper title documents like shares, bonds, debentures, etc., then financial risk will be involved. And financial risk is different from business risk. Business risk arises from the nature of firms' businesses. Strategic risk, compliance risk, financial risk, and operational risk are the part of business risk. And profit is risk-bearing award, according to Professor Hawley. When we will not bear any type of risk, then we will not earn profit. So, in business or in financial securities, risk is definitely involved. And financial risk arises from possible losses in financial markets due to movement in financial variables, usually associated with leverage, with the risk that the obligations and liabilities can't be met with present asset. So financial risk generally arises due to loss in financial markets. If financial market is bearing losses, then no one will be interested to invest their money in financial markets. And if any business or corporate sector is bearing losses, then no one is interested to invest their money in their securities like shares, bonds, debentures, etc. So financial risk arises from possible losses in financial markets due to financial movement in financial variables. Next is types of financial risk. There are so many types of financial risk which involved in financial market. First is market risk. Second is credit risk. There are 4 broad categories of this financial risk. We can classify financial risk into 4 broad categories. One is market risk, second is credit risk, Third is liquidity risk, and fourth is operational risk. In market risk, absolute risk, relative risk, directional, non-directional, basic risk, and volatility risk is involved. In credit risk, credit event, sovereign risk, and settlement risk is involved. In liquidity risk, in this asset liquidity and funding liquidity, it's also a very big risk that sometimes any business corporate sectors or business enterprises, they have lack of liquidity of asset. So this risk also arises in business enterprises. Sometimes assets may be less than their requirement, and sometimes assets will be more than their requirement. So asset liquidity, liquidity because finance is more liquid asset, more liquid form of asset. Money is very liquid form of asset according to Keynes. Keynes was the great economist who gave macroeconomic theory. And the general theory of employment, interest, and money, this book was published by J.M. Keynes. So liquidity risk also arise in financial market. Sometimes demand for finance is more than the supply of finance. And sometimes supply of finance is more than the demand. Demand may be less, demand may be more. Depends upon business conditions. If there is a boom situation exists in the economy, then demand for financial securities will rise. And if there is a depression or recession situation exists in the economy, then demand for finance will fall. So liquidity risk also arises in financial market. And credit risk means sometimes lenders are not interested to lend their money to the borrowers, because if borrowers are not reliable, if borrowers don't give payment of interest and give back all the borrowed money at time, then lender will not be interested to lend their money to those borrowers who are not reliable and who are not paying interest on time. So this is called credit risk. And in market, you know that market is very dynamic. Economy is very dynamic. Each and everything is changing. So there is too much market risk is involved. And fourth is operational risk. Operational risk, in this fraud risk, people risk, model risk, and legal risk involved. Operational, smoothly operational of financial market is very necessary for the smooth working of financial instruments. So if financial market is not working smoothly due to these operational risks like fraud risk, people maybe do fraud, some securities are not genuine or reliable, sometimes they issue mutual funds and shares but not give any benefit to the shareholders or bonds holder, then it means they are doing fraud from the public and they are doing illegal activities under this financial market. If illegal activities are involved in financial market, then financial risk will increase. And due to increase in this risk, trust of investors, trust of savers will down. So these are the financial risks which involved in financial market. Next is regulation of financial instruments. The Reserve Bank of India, you know that RBI is the apex institution of monetary authority. RBI has a legislative mandate to regulate the interest rate and foreign exchange markets, which are critical for the resilient functioning of the financial system and the broader economy, and for ensuring economic stability or financial stability. As part of this mandate, the RBI is tasked with the regulation, development, and oversight of the interest rate markets, including the government securities market, money market, including the market for repo in government securities and corporate bonds, foreign exchange market, derivative market, interest rates, prices, foreign exchange rates, and credit. All things are managed by Reserve Bank of India. The Reserve Bank is also responsible for the regulation of financial market infrastructure, including financial market benchmarks for these markets. The RBI regulates financial markets within the overarching statutory framework of the RBI Act 1934, the Government Securities Act 2006, Foreign Exchange and Management Act, which is known as in short FEMA, FEMA, Foreign Exchange Management Act 1999, the Bilateral Netting of Qualified Financial Contract Act 2020, and the Payment and Settlement System Act 2007. It means RBI regulates all the financial markets under some specific act and provisions. By these provisions, by these act, RBI can regulate financial instruments. Now, we will start elementary statistics, block number 2, unit 4 and unit 5. Statistics is the basic thing in each and every sector. We must have to know about what is the meaning of statistics and where we can apply these statistical instruments or statistical tools. In today's life, each and every thing involved statistics or data. In all economic activities, in all businesses, in all government policies, in each and everything, statistics play a very important role. Statistics may be defined as a science of collection, presentation, analysis, and interpretation of numerical data. Statistics include 4 terms. One is collection of data. First of all, we have to collect data. Through collected data, we can analyze it and we can interpret it, and in last, we can conclude it. So collection of data is very necessary while using the statistics, while defining the statistics. Second is presentation of data. Presentation of data is the main instrument. We can present the data in form of graphs, bar graph, subdivided bar graph, multiple bar graph, pie chart, and other so many graphs like histogram, frequency polygon, frequency curve, etc. Next is analysis of data. We have so many tools of analysis of data, like measures of central tendency, measures of dispersion, correlation and regression, and so on. And next is interpretation of data. with the help of these statistical tools, we can analyze the available data and we can interpret it. And in last, we can conclude it. So statistics, we can define that statistics is a branch of mathematics in which we can show or we can present each and everything in terms of data, or in numerically we can express it. Next is meaning of statistics. Statistics can be defined because it is concerned with statistical or scientific methods for collecting, organizing, summarizing, presenting, and analyzing data, as well as deriving valid conclusions and making reasonable decisions on the basis of this analysis. Statistics is concerned with the systematic collection of numerical data and its interpretation, because without interpreting we can't conclude, we can't make conclusion. So data collection is the first thing or first function of the researcher or any investigator, and the last thing is analysis of data and interpreting of data, because without interpreting the data we can't make any conclusion, we can't get results. So statistics is a very systematic thing. Statistics is a scientific method for the collection, presentation, organizing, summarizing, presenting, analyzing, and deriving valid conclusion basis of this analysis. Statistics is concerned with the systematic collection of numerical data and its interpretation. The word statistics is used to refer numerical facts. When we express anything in terms of numerical data, that is called statistics, such as the number of people living in particular area, we can express in numerical terms. The study of ways of collecting, analyzing, and interpreting the fact is known as statistics. Statistics has two main types. One is descriptive and other is inferential. So there are two types of statistics, descriptive and inferential. In descriptive statistics, we organize the data and summarize the data. These two things are included in descriptive statistics. And inferential statistics, with the help of this branch of statistics, we can make conclusion, we can draw conclusion with the help of this inferential statistics. So descriptive statistics has another parts. One is tendency descriptive, spread descriptive, and confidential interval inferential is the part of inferential statistics, and hypothesis inferential is also the part of inferential statistics. So there are two parts of descriptive statistics. One is organizing of data, other is summarizing of data. In other terms, we can use this tendency descriptive and spread descriptive. And in inferential statistics, we can draw conclusion from the above interpretation of data, that is confidence interval inferential, and next is hypothesis inferential. So these are the types of statistics. Next is application of statistics. How we can apply the statistics in different fields of the economy. You know, applications of statistics tells us that where we can use the tools of statistics, where we can apply the branch of statistics like descriptive and inferential. Statistics play very important role in all over the world. In each and every activity, we can apply the tools of statistics. In financial economics, You also can apply this statistical tools, because statistical tools can be used in accounting branch, in banking system, in controlling system, in marketing, production, finance, investment, purchase, each and everything use statistical tools. That's why application of statistics can be explained with the help of this chart. This chart is showing that in marketing, in production, in finance, in investment, in purchase, in accounting, in banking, and in controlling, in everywhere we are using the tools of statistics. Next is importance of statistics. Statistics is very important and it play very important role in economy. You know that in economy, businesses or corporate sectors are playing very important role in production of goods and services, because agriculture sector provides us raw material. But businesses provide, or enterprises or manufacturing sector provide us finished goods. So in businesses, statistics helps to make swift decisions by providing useful information about customer trends and variations, cost, customer trends and variations, price, customer trends and variation. It means if we want to set the price of any commodity, if we want to decrease the cost of production, and if we want to get information regarding customers' demand, then we need numerical data or statistics. In mathematics, statistics also play a very important role. It helps in describing measurement and providing accuracy of theories. In economics, it also plays a very important role. Economics may be financial economics, economics may be public finance, economics branch may be microeconomics, macroeconomics, agriculture economics, industrial economics, and statistics is also the part of economics. So it helps to find relationship between two variables like demand and supply, cost and revenue, imports and exports. It helps to establish relationship between inflation rate, per capita income and social welfare, income and distribution, national income and standard of living of the country people. We can explain the relationship between two variables with the help of correlation, and correlation is the tool of statistics. That's why statistics can be used in each and everything, and it is very important in all these things like businesses, mathematics. We use statistical tools, we use statistics, and in economics, statistics play very important role. And for forecasting weather, statistics is also very necessary. Next is applications of statistics. In computer science, we can use this statistics. In computer science, client-server performance, image processing can be done by statistics. Chemistry and physics, determining outliers in your data, linear regression, propagation of error, dealing with large population and approximation, all these things use statistics. In engineering profession, statistics is very useful. Statistics is one process or technique better than another one. In businesses, it helps in making good decisions or best decisions. In everyday life, like medical information, average cell phones uses of uh, produce students. So everyday life we use these statistics. So we can say that application of statistics cannot be defined in a narrow sense. Application of statistics is a very broader and very wide aspect. We can study this and we can use statistics in each and every activity of the economy. Next is, what is statistics? Here this application area is, we can classify, we can make this just like this is a payoff matrix. Here in economics we use statistics, in engineering we use statistics, in sports we can use statistics, and in businesses statistics is very useful. In economics, why we use statistics? For making forecasting and for making data, collecting data of demography or population. In engineering, constructions and materials, we use statistics. In sports, individual and team performance, we can get the knowledge regarding this individual and team performance by statistics. And in businesses, consumer preferences and financial trends can be studied with the help of this statistics. So this is the application area of statistics. Next is collection of data. In statistics, first of all, we have to collect data, because without collection of data, we can't do anything. So collection of data is very necessary while using this statistics term in any business enterprises or in any field. So collection of data, the introduction of this thing is, data collection is in fact most important aspect of statistical survey. The term data used in statistics means quantitative data. In other words, in data, we include the information which is capable of numerical expression, that is called quantitative data. Generally, when we express anything in terms of numerical terms or in terms of data, that is called, when we can quantify it, then we can say that it is a quantitative data. But some facts are related to qualitative. And in qualitative aspects like intelligence, honesty, good or bad, has no significance in statistics until and unless these are assigned some figures. So qualitative aspects, when expressed numerically, can be studied in statistics. So data may be quantitative and data may be qualitative. Quantitative data is that data which can be quantified, and qualitative aspects are those which can't be quantified sometimes, but if we can give ranks according to our preferences, and then we can quantify it, and then we can study it in statistics. So collection of data is basically of two types. One is quantitative and other is qualitative. And data collection, there are two types of data collection. One is primary data and secondary data. Data are basically of two types. One is primary data and other is secondary data. Primary data is that data which is very original in terms, which is firstly collected by that person who are doing research or who are doing investigation, who want to collect original data. Then primary data collection method is very useful. The examples of primary data are surveys, interviews, opinion polls, questionnaire, etc. And secondary data is that data which is collected by some institutions or organizations which are already collected by some other person but used by other persons. For example, this type of data is known as published data. If data is already published by government institutions, government agencies, business organizations and IMF, World Bank, yeah, or ILO. Yeah, it means if foreign institutions or government institutions or World Bank has collected data already, and if we are using that data for our purpose of research, that is called secondary data. Secondary data, for example, companies' annual reports, sales record, internet information, all these things are already collected by some other one person and used by other persons. So secondary data is less original than primary data. But primary data is more original and more useful and more reliable than secondary data. But sometimes primary data we can't collect it because if we have lack of time, if we have lack of resources, then we can't use this primary data. We have to use secondary data for making conclusion and for making our research purpose. Sometimes secondary data is used by researcher because primary data the person is not able to collect that. So there are two types of data collection method. One is primary and other is secondary. In primary we include surveys, interviews, opinion polls, questionnaire, etc. And in secondary we include reports of RBI or RBI bulletin or company's annual report, sales record, internet information, World Bank data, IMF data. Generally it is known as primary data because some data we can't collect, which is collected by other foreign institutions or international organizations like WHO, World Bank, IMF. These data are generally called primary data, either it may be published or not. Next is data organization and presentation. After collecting the data, second main function is data organization. And after that, we can present that data in form of graphs. So data organization is very important. After the collection of data, we can organize the data because scientists use written reports and oral presentation to share their results. Organizing and presenting the data are important science skills. So we will look at three different ways to organize and present data. One is data tables. Second is graphs. We can make or we can draw graphs like bar graph, pie chart, line graph, histogram, polygon, frequency curve. So many graphs we can draw and models. So data organization and presentation include these three things: data tables, graphs and models. Next is stages of statistics are five. One is collection of data. Collection of data is the first stage of statistics, and the tools of collection of data is census or sample techniques. We can collect data from primary and secondary sources, and we can collect data through these census or sampling methods or techniques. Census method is also known as population, in which we study about whole population, not a part of that. But in sampling technique, we use some samples from the whole population and draw conclusion. Sampling technique is generally used by those person or in those areas or in those sectors where all the units are homogeneous. If there is a heterogeneous unit, then we must have to study and we must have to collect data through census method. But census method is very costly, very time-taking process. Sampling technique is very simple, less costly and used by everyone because this sampling technique is less time taking. That's why generally researcher or investigator prefer this sampling technique. So stage 1 is collection of data in which census or sample techniques we can use. In stage 2, organization of data is included. In this, data can be organized with the help of tally bars and array of data and tally bars, because when we collect the data, that is called raw data. And raw data, we have to arrange it either in ascending order, in descending order, and we have to make frequency with the help of tally bars. That is called organization of data, and this is the second stage of statistics. Third stage is presentation of data. We can present the data with the help of tables. Table is a tabular presentation of any given facts or in any given data. When we present the given information or available information in form of rows and columns, that is called table. And we can also present our data with the help of graphs and diagrams. Stage 4 is analysis of data. In analysis of data, we can use percentage and averages. We can analyze the data with the help of measures of center tendency like mean, median, mode, measures of dispersion like standard deviation, mean deviation, range, quartile deviation, etc. And stage 5 is interpretation of data. After doing all these stages and after covering these stages 1, 2, 3 and 4, in fifth stage, we can interpret the data. In this magnitude of percentage, averages, degree of relationship between different variables, we can draw conclusion, we can interpret it, then the whole process or whole stages will be covered. So these are the stages of statistics, statistical study and statistical tools which we use for the use of statistics. Next is presentation of data. Presentation of data is also very necessary when we express any numerical fact or any quantitative data in form of diagrams. Diagrams are equivalent. One diagram is equivalent to 1,000 words. If we draw one diagram, then there is no need to describe any other thing. That diagram will also sufficient for the description of that thing which we are showing with the help of that diagram. So data can be expressed or can be shown with the help of following ways of presentation. Like presentation of data can be done by with the help of tabular presentation and graphical presentation. Presentation may be tabular, presentation may be done by graphs. So in tabular presentation, we can make simple table and we can draw complex table. For example, if we are showing the students of class 11th and class 12th, that is called simple table. But if we are showing that student of class 11th in rural area and students of class 11th in urban area, after that again we classified it in male or female, and that is called complex table. And students of class 12th in urban area, again in rural area, again in divided into in male and female, so that is called complicated table. But in simple table, we are showing only students, the numbering of student in class 11th and class 12th. That is simple table. But this simple table can be classified into another parts. Like in rural area students, urban area student, male student, female student. In rural area, male student and female student in urban area. Then this table will be called complicated table. Next is graphical presentation. Presentation may be done by graphs. For quantitative data, we use these graphs like histogram, frequency polygon, frequency curve, line chart, normal distribution curve, which is known as bell-shaped curve. This bell-shaped curve is also show that distribution is equal and the values of mean, median and mode are equal. And next is cumulative distribution curve, which is known as ogive curve, which shows that median, how we can uh, calculate median. Where cumulative distribution curve, which has two types, less than ogive curve and more than ogive curve, where both curve intersect each other, median is determined with the help of cumulative distribution curves. And next is scatter diagram. Scatter diagram is the way of presenting variables with the help of graphs. If we are showing two variables in a graph, then we can show that the relationship between these two variables without using any statistical tool or any numerical terms. With the help of this scatter diagram, we can show or we can explain the relationship between two variables or more than two variables. That relationship may be positive, may be negative, or may be zero. So scatter diagram is a very good way to show relationship between variables. And for qualitative data, we use graphs like bar chart, pictogram, pie chart, and map diagram. So there are different ways of showing data in graphs. Like if we have quantitative data, then we use these 7 methods. And if we have qualitative data, then we will use bar chart, pictogram, pie chart, and map diagram. This is called presentation of data. Next is measures of central tendency. Measures of central tendency is a very important thing, and measures of central tendency tells us about mean, median, mode, from which we can use our collected data in numerical terms, and we can get conclusion and we can draw conclusion with the help of these measures of central tendency. So in statistics, a central tendency is a central value or a typical value for a probability distribution. It is occasionally called average or mean, or just the center location, center of the distribution. The most common measures of central tendencies are mean, median, and mode. These three are very important measures of central tendency. Measures of central tendency are defined for a population. Population means whole, and sample is the part of population. So if we are studying about whole thing, that is called population. Here population doesn't mean the country's population. Here population means we are studying. If we are studying about 2000 number of people, that is called population. And if we are studying about only 50, the part of that population, if we take some samples out of 2000 persons or people, that is called sample. So population is the large set of observation of similar nature, and the sample is the proportion of the observations of a population. So measures of central tendency can be defined as for population and sample also. Next is the key concepts of measures of central tendencies are the three main principal measures of central tendency are the mean. Mean is the average, or median. Median is the mid value of the frequency distribution, and mode. Mode is the highest frequency value. The measures for a sample can differ from those for the whole population. The mean is the sum of all the observations. If we add all the observations and divided by the total number which we have already given, then we can get mean or average. So the mean is the sum of the values in a set of data divided by the number of values in the set. The median is the middle value when the values are ranked in order. If there are two middle values, then the median is the mean of these two middle values. While calculating median, first of all, if individual series is given, then we have to, first of all, we have to arrange that data either in ascending order or in descending order. Then we will use formula like n plus 1 by 2 for calculating median. So median is the mid value of given frequency distribution, in which in the beginning the digits will be less and after mid value the digits will be more. So median is the mid value of the given series, and mode is the most frequently occurring values. And outliers can have a dramatic effect on the mean if the sample size is small. Outliers are generally called if we use that data, like if we are taking 2, 4, 6, 8 and again, and after that generally we take less values, but if we take 128, the values are very small like 2, 4, 6, 8, but suddenly the value come 128. This 128 is called outlier because this value is very higher, but the other sample size value is very small, very less. So outlier can have a dramatic effect on the mean if the sample size is small. A weighted mean can be useful measure when all the data are not of equal significance. For data grouped into intervals, the mean and median can be estimated using the midpoints and frequencies of the intervals. So these are the key concepts of measures of central tendency, in which mean, median, mode. Mean has again three parts: geometric mean, simple mean and harmonic mean. Median is the mid value of the given series and mode is the frequent occurring value or highest value in the given series or the most frequent value of the given series. Next is measures of dispersion. Measures of dispersion, under this we can use range, variance and standard deviation. Measures of dispersion tells us how much spread of data set is given. When we are calculating the scatteredness of data or how much spread of data is given, then we use this measures of dispersion. The mean, median, mode is usually not by itself a sufficient measure to reveal the shape of a distribution of a data set. We also need a measure that can provide some information about the variation among data set values. The measures that help us to know about the spread of a data set are called measures of dispersion. The measures of central tendency and dispersions taken together give a better picture of a data set. We consider three measures of dispersion. Generally, we have so many measures of dispersion like range, variance, mean deviation, standard deviation, etc. So three main measures of dispersions are range. Range tells us the highest and lowest value of the given series. If we take the difference between highest and lowest, then we can calculate range. Variance tells us variability of the given data, and standard deviation is based on averages or mean, and it is the square root of averages. Next is sampling techniques. Sampling techniques are generally two types of techniques. One is probability, other is non-probability. Sampling technique is that technique in which we use to collect data from this sampling method. Sampling method generally used where all the units are homogeneous, and sampling techniques are those techniques which can be classified into two parts. One is probability and other is non-probability. Probability or random sampling is the best way of sampling technique because in this we use and we provide the chance of each and every unit to include in the sample. So simple random sampling is that technique in which all the units has given equal chance for the occurrence for collecting the sample. So simple random sampling is the first probability sampling technique. Other is systematic sampling. Systematic sampling in which we use a system, like if we collect the samples by alphabetically or geographically, that is called a simple or system. Systematic sampling generally used a particular system for collecting samples through this sampling technique. And stratified sampling, in this method, first of all, we have to make strata or levels. We have to classify the whole population in some groups, and then we can collect samples from these classified groups. That is called stratified sampling. Cluster sampling is that sampling in which we have to make some broader information into narrow information. If we are taking a broader area, then again and again we are reducing, and after that we take some sample which is necessary for our research or for our knowledge. Then that is called cluster sampling. And next is area sampling. We can collect samples from particular area, particular geographical area or location, and multi-stage sampling which can be applied in different stages of our study. These are the techniques of probability sampling. Non-probability or non-random sampling techniques are judgment sampling. These are not reliable. Probability sampling techniques are much reliable than non-probability sampling techniques because non-probability sampling techniques are based on bias of the investigator or researcher. Non-probability or non-random sampling techniques are judgment sampling, convenience sampling, quota sampling, panel sampling, and snowball sampling. These techniques are generally very simple and very less reliable because these all sampling, non-probability sampling techniques are based on convenience of the researcher or investigator, judgment of the investigator, and these techniques are based on whole opinion of the researcher. So that bias possibility much more exists in non-probability sampling techniques. But bias is not possible, and bias can be avoided. Partiality can be avoided in probability sampling techniques. That's why probability sampling techniques are more reliable than non-probability sampling techniques. Next is probability and non-probability sampling techniques are different, like sample is selected at random, but in non-probability samples selected based on the subjective judgment of the researcher. is possible in non-probability sampling. Probability sampling, finding the right respondent is not easy. Finding the right respondent who give the correct information, that is the biggest problem while using probability sampling. But in non-probability sampling, finding respondent is easy. So this is the basic difference between probability sampling and non-probability sampling. Next is sampling error. When we use this sampling technique, then sampling error can be exist. Sampling error arises due to the sampling technique used to draw a sample. Non-sampling error arises due to use other non-sampling techniques. So both the errors can be controlled but can't be made zero. Complete enumeration is free from sampling error but is subject to non-sampling error. Sample survey is subject to both sampling and non-sampling error. So error generally arises when we do any mistake while collecting samples from population. So we have to avoid this sampling error if we want to make our result more accurate or more reliable. Next is data is basically of two types. One is univariate and next is bivariate. Sometimes data may be multivariate. Univariate data is that data in which only single variable exists, and bivariate data is that data in which two variables exist. Univariate data does not deal with cause of or relationship, but bivariate data can be used for showing cause and relationship between two variables. If we have only single data, how we can show the relationship between other thing? Because we have only one data. So if we have single variable, we can't make any cause or relationship. So univariate data does not deal with cause or relationship. But bivariate data is the main thing of showing cause or relationship. Major purpose of univariate data is to describe, and the bivariate data, the main purpose of this is to explain. So univariate data is just like mean, median, mode, dispersions like range, variance, maximum, minimum, quartile deviation, standard deviation, frequency distribution, bar graph, histogram, pie chart, line, graph, box, and whisker plot, that all are called univariate data. And in bivariate data, analysis of two variables, correlation, regression, comparisons, relationship, causes, explanation, tables where one variable is contingent on the other, on the values of the other variable, independent variable or dependent variable. So these are the examples of bivariate data. The sample question is under a univariate data is how many of the students in the freshman class are female. And sample question of bivariate data is that is there a relationship between the number of females in computer programming and their scores in mathematics. So if we are using two variable, that is bivariate, and if we are using only one variable, that is univariate. Next is bivariate data. We can define if two sets of data representing different variables, that is called bivariate. Bivariate data is studied to see if the two variables are related in any way. So bivariate data studies always two variables or show relationship between these two variables. Next is hypothesis testing. Hypothesis is a theoretical statement that concerns a certain features of the studied statistical population. This hypothesis testing is included in inferential statistics. So hypothesis testing, null and alternative hypothesis, estimation, Microsoft Excel spreadsheet program, introduction to Excel, Microsoft Excel, all these things we will do in next session or upcoming session. Now, from the today's session, we can draw conclusion that good statistics and sound statistical analysis assist in providing the basis for the design of policies and plans. monitor policy implementation and implications, achieve issues recognition, evaluate policy impact, and forecast the future. So, evidence based policy making is desirable because it enhances the transparency of policy making and the accountability of policy makers. So, statistics is very useful in financial economics and each and every field of the economy. That's why you must have to know about the elementary statistics, and in next session we will do spreadsheet and the remaining topics which we can't cover in today's session. So thank you.